About 94% of it sits beneath the Pacific Ocean, most of it a mile or more straight down, which sounds like a perfectly good reason nobody noticed a continent 2/3 the size of Australia. That is the explanation almost everyone gives. The ocean swallowed it, so the ocean hid it. At least, that is what people assume. The water was never really the problem. Zealandia went unrecognized for 375 years because nobody in the history of science had ever bothered to write down what a continent actually is. The Tasman Sea, December of 1642. A Dutch captain named Abel Tasman was sailing 2 ships across open water in the service of the Dutch East India Company, and he was looking for something that did not exist. European geographers had been passing around the idea of a great southern landmass since the days of Ptolemy. They called it Terra Australis, the unknown southern land, and they were so confident it was down there that they drew it on maps before anyone had seen it. Tasman had orders to find it. What he found instead was a rugged coastline of forested mountains rising out of gray water. He anchored offshore. The people who already lived there, the Maori, came out to meet the Dutch ships in canoes, and the encounter went badly. A canoe rammed a small boat that was passing messages between the 2 vessels. 4 of Tasman's men were killed. Tasman never set foot on the land. He raised anchor, sailed north, and wrote the coastline into his charts as an interesting but minor discovery. In his own judgment, he had failed. The strip of coast he had seen was far too small to be the great southern continent Europe was expecting. He was looking for something the size of a world. He had found what looked like a few islands. He was floating directly above the answer, and the shape of it stretched for well over 1,000 miles in every direction beneath his hull. For the next 2.5 centuries, that was where the matter sat. The islands got mapped in detail. Cook came and charted the coasts properly. Settlers arrived, cities grew, and the land Tasman had dismissed became New Zealand. Nobody had any particular reason to wonder what the seafloor around it looked like, because in the 1600s, the 1700s, and most of the 1800s, the seafloor was effectively invisible. You could not see it, you could not measure it, and you certainly could not sample it. Then someone noticed the rocks were wrong. Sir James Hector was a Scottish naturalist and geologist working in New Zealand, and in 1895, he did something nobody had thought to do. He surveyed the scattered chain of islands sitting off the southern coasts, the lonely specks of rock hundreds of miles from anywhere, and he looked at what they were made of. They were not the sort of thing that volcanic islands are made of. They were continental, granite and old, complicated, layered stone. The kind of rock that belongs to a landmass, not to a lump of lava that punched up through the ocean floor. Hector wrote it up and published his conclusion. New Zealand, he argued, was the surviving remnant of a much larger landmass that had gone under the sea. He put it into the record in the proceedings of the Royal Society of New Zealand, and it landed with almost no impact at all. The paper went largely unnoticed and stayed that way. He was right. He had, in essence, called it 122 years before the scientific community agreed with him. He had no way to prove it. That is the part that matters. Hector could look at rocks on beaches. He could not look at the seafloor, because in 1895, nobody could. He had an idea and no instrument, and an idea without an instrument is just a suggestion. Pay attention to that gap, because it explains everything that follows. So what was actually down there? Around 85 million years ago, the southern supercontinent called Gondwana was coming apart. Antarctica, Australia, South America, and a fourth piece were all pulling away from one another along a series of tearing, stretching fractures in the crust. That fourth piece is the one we are talking about. As it separated, its continental crust was pulled and thinned in a way the others were not. Continental crust normally runs somewhere between 30 and 45 kilometers thick. Zealandia's got stretched down to roughly 20. Thin crust does not float as high, so it sank. The whole landmass settled downward until the sea came in over the top of it, and everything except the highest ground disappeared beneath the Pacific. Around 40 to 50 million years ago, the volcanic chain that would become the Pacific Ring of Fire buckled and reshaped it again, folding the drowned terrain into ridges and troughs. What was left above water was New Zealand, New Caledonia, and a scatter of islands. What was left below water was the other 94%. And it was not empty ground before it went under. When drill ships finally cored into the sea floor of the Tasman region, they pulled up cylinders of sediment from thousands of feet below the seabed, and the sediment was full of life. Researchers studied more than 8,000 specimens and identified several hundred fossil species. Microscopic shells from creatures that lived in warm, shallow seas, spores and pollen from land plants, not deep ocean organisms, coastal ones, shoreline ones, things that lived where there was land. On the Chatham Islands, out in the empty water east of New Zealand, paleontologists have found bones from sauropods and ankylosaurs. Dinosaurs walked on this thing. There are foot bones out there from animals that lived long after Zealandia broke away from Gondwana, which means chunks of it stayed above the waterline and stayed habitable for a very long time. Those cores went down through thousands of feet of seabed and pulled up something like 70 million years of continuous history, layer by layer. And the deeper the drill went, the clearer it became that this was not ocean floor. It was drowned land. The people who arrived on the surviving peaks had their own word for the shape of it long before any of this. In New Zealand, the continent carries the name Te Reo a Maui, which refers to the hills, valleys, and plains of Maui, the demigod who in Maori tradition hauled the land up out of the sea with a fishhook. A story about a landmass being pulled out of the ocean, told for centuries by people living on the only part of it that ever came back up. So the picture assembles into something genuinely strange. A continent with mountains and forests and dinosaurs, which slowly, over tens of millions of years, lowered itself into the Pacific Ocean like a ship settling. And in the end, only the peaks were left. And people sailed to those peaks and built cities on them and called it a country. If you are enjoying this, take a second and hit subscribe, because this channel goes deep on exactly this kind of thing every week. By the 1990s, the seafloor was no longer invisible. Satellite gravity mapping could sense the mass of rock sitting under the water. Bathymetric surveys could trace the shape of the ocean bottom. Deep sea drilling could bring up actual samples. Every instrument James Hector had been missing now existed, and the picture they produced was unmistakable. There was a vast, coherent, continental-looking plateau down there, thicker and higher than the ocean crust around it, running for thousands of miles. In 1995, an American geophysicist named Bruce Luyendyk gave it a name: Zealandia. And then the scientific community looked at all of that evidence and filed it under microcontinent. Not a continent, a fragment, a submerged plateau, a large piece of continental crust that happened to be lying around near Australia. For decades, that was the official framing, and nobody could explain what made it a fragment instead of a continent, because nobody could explain what a continent was. I mean, sit with that for a second. Geology, a field built on classification, a field that has formal definitions for hundreds of rock types, and a naming convention for every layer of every era, had never sat down and defined its single largest unit. Everyone knew what a continent was in the way that everyone knows what a chair is. 7 of them. You learned them in school. The word was inherited, not tested. And because it was never tested, there was no checklist to run Zealandia against, and with no checklist, the default answer to a novel case is always no. You would think someone would have said something. Nobody did. That is the real lock on the door, not the water. The water is only 2 kilometers of it, and by the 1990s, we had machines that could see straight through 2 kilometers of water. The thing that kept a continent off the map was a blank space in the dictionary. In 2017, a team led by the New Zealand geologist Nick Mortimer decided to fill it in. Their paper, published in the Journal of the Geological Society of America, did the boring, unglamorous, absolutely necessary thing. It laid out what a continent has to be. 4 criteria. It has to sit distinctly higher than the surrounding ocean floor. It has to be made of a wide variety of continental rock types rather than just one. It has to have crust that is thicker than oceanic crust. And it has to have well-defined limits, a coherent boundary rather than a smear. Then they ran Zealandia through it. Elevation, yes. It stands well above the abyssal plain around it. Rock variety, yes. Granite. Sedimentary layers. Volcanic rock. Metamorphic rock. The full continental spread. Crust thickness, yes. Around 20 kilometers. Against the 7 or so of typical ocean crust. Defined limits, yes. Its edges are traceable all the way around. 4 out of 4. It is not a fragment. It never was. It is a continent that happens to be underwater, covering 4.9 million square kilometers, which is nearly 1.9 million square miles, larger than India, and roughly 2/3 the size of Australia. The smallest continent on Earth, the thinnest, and the youngest. 375 years after Abel Tasman looked at it and decided it was too small. The argument still had to be finished, and finishing it took another 6 years and a lot of rock. In 2023, Mortimer and an international team published a second paper, this one in the journal Tectonics, dealing with the northern 2/3 of the continent, the part that nobody had properly surveyed. Their evidence came from dredging. An Australian research vessel hauled rock samples off a submerged ridge in the Coral Sea, and the lab work told a very clear story. Sandstone from about 95 million years ago. Granite cobbles dated to 111 and 128 million years. Basalt lavas from the late Eocene, around 36 to 40 million years ago. Combined with magnetic anomaly data across the region, that let them draw the basement geology of the northern half and place the axis of the ancient magmatic arc that once ran along Gondwana's edge. With that map finished, the reconnaissance geological mapping of the entire 5 million square kilometer continent was complete. For the first time, someone had drawn all of it. Andy Tulloch, one of the geologists on the project, described it as an example of how something completely obvious can still take a very long time to uncover, which is a remarkably gentle way to put it. The work has not stopped. Later studies have argued about how exactly the breakup happened, whether the continent tore away sideways or whether it was stretched and thinned until the ocean poured in. And more recent seismic surveys keep refining the architecture of the drowned edges. There is no international body that certifies continents, so nothing was ever stamped and made official. What happened instead is what usually happens in science. A case was made well enough that arguing against it became the harder position. What the recognition does change is who gets to argue about the seafloor. Under international law, a country's rights over the seabed depend heavily on whether that seabed is a natural extension of its landmass. Establish that the plateau under the South Pacific is a coherent continent rather than a scatter of unrelated fragments. And you have redrawn the terms of every conversation about the minerals, the energy, and the fisheries sitting on top of it. A definition written in a geology journal quietly becomes a line on a very expensive map. The lesson buried in Zealandia is not really about geology. For 3.5 centuries, a continent sat in the South Pacific with millions of people living on the top of it. And the reason nobody counted it was that the question had never been asked properly. The evidence was gathered. The rocks were on the table. Hector had the right answer in 1895 and simply could not prove it. And after the instruments caught up, the missing piece was not another survey or another drill core. It was a definition. Somebody had to be willing to ask what the word actually meant. There are almost certainly other blank spaces in the dictionary right now, sitting under other oceans, waiting for someone to notice that the category was never checked. The seafloor covers most of this planet, and almost none of it has been mapped in real detail. Somewhere down there in the dark, the next thing we have been looking straight past is holding perfectly still, waiting for the right question. Thank you for watching. If you enjoyed this video, please feel free to like and subscribe. And if you'd like to continue watching more of my videos on science mysteries, you can click the video on the screen now.